My name is Chan Hellman. I'm a professor at the Department of Human Relations, Norman-based program located here on campus. I'm a quantitative psychologist, so I rarely get to talk about this stuff, so I'm just thrilled to death on a Friday afternoon to be talking about reliability. I told you the other day that I had some stat jokes, and I've been desperately trying to remember some of them so that, as you go into your weekend, you can share them with your circle of influence. But just as kind of a start, so I'm a quantitative psychologist, and what that really means is that when the zombies come, right? When the zombies come, and you guys need somebody with good, solid statistical theory, I'm your go-to guy, okay? Which probably means when the zombies come, I'm the first one you'll want to trip to give yourself a little bit of time. So I would argue I can carry wood. All right, so today, the first day, again, this series of 3 sessions was meant to build upon each other, but also to stand alone. And again, my primary objective in this series was to be skills focused rather than philosophical and formula and stuff like that. So everything sort of culminated to today. The first day was kind of the boring lecture piece. The last time was a little bit more active in terms of finding and evaluating measures, just a real cursory review. Today we're actually going to use SPSS, which is a statistical package for the social sciences, which OU has site license for. So if you have an OU computer, you can have SPSS downloaded to that computer, right? So if you don't currently have access to it, your workstation can have it because we have a site license for that. If you have a university-owned laptop, you can get it on there as well. Okay, so so today we're going to analyze some data that I've collected. We're going to do some reliability analysis. In particular, we're going to focus on internal consistency reliability. So I've got a database that will allow us to determine both good and perhaps poor indicators of score reliability, and to talk about conditions under which score reliability starts to fall apart, okay? But what I really want to make sure that I highlight is that all of our publication manuals, regardless of APA, AMA that you follow, and all of the editors, basically highlight the idea that you should provide the statistical analysis or reliability estimates of the measures for your sample. And oftentimes we read articles that will say a couple of things. One, we've already talked about this, is that the authors will state something like the test was reliable or the test was valid. And what we need to remember is that it's not about tests, it's about the scores obtained from a test. Tests are neither reliable nor unreliable, okay? It's the scores obtained from the tests that present that. So it's actually not appropriate to say a test is reliable or valid. It's about the scores. Can't emphasize that enough. The second thing that you might see is that somebody might report, I use the Snyder Adult Hope Inventory, and Snyder reported adequate reliability estimates. That is, I'm reporting reliability, but I'm reporting reliability that Snyder's research found, right? And that's probably fairly common. That as you're reading through it, so they'll refer to somebody else's study that established the reliability. That also is inappropriate because reliability scores are sample specific, and again, our publication guidelines say we should report this for our sample. Okay, so what I want to do today is simply show you how to do that, and it is one of the most simple processes in SPSS. So anyway, let's walk through it. There's a couple of different ways to get your database opened up in SPSS, and probably the easiest way once you have it downloaded to your desktop is just to double click it. Okay, So it automatically will open up. That's why I have you save it to your desktop. You can just double click it. Otherwise, you have to open SPSS and then go find the data file, and just like you would normally open a file. How many of you have used SPSS? About half the room. So one of the things that you'll notice is that SPSS, outside of color, basically is set up very similar to Excel, to an Excel spreadsheet. And Excel actually has a pretty nice statistics package, and then it also has some data packages that you can download, data analysis packages that you can download. I've been doing SPSS for about 30 years now, so I don't know how to use Excel, so I don't use it. So I grew up with SPSS, so that's what we're going to do. But what I would tell you is that from a statistics standpoint, Excel, while appropriate, SPSS is the sledgehammer. I mean, it's just a very powerful statistical tool with complex statistical analyses built into the system. So I think the graduate package is like $100 or so. Is it still about that? So
we just bought it for 2 licenses for $77.
Yeah, so the graduate packages are actually pretty reasonable as software databases go. The problem with it is that it's based upon dates now, right?
12 months.
Yeah, whereas in the old days they'd give you the disk.
Well, no, we could add the disc for $10 or something.
I would do that personally. Well, it still is time stamped. Yeah, it's still time stamped. So anyway, rows and columns. So rows equal an individual or a case, and column equals the variable. Okay. Now, one of the things that I also had emailed to you was the actual survey that generated this data. So you can kind of see that if we start from where we were the last time where we were finding and evaluating measures. Did anybody print that out? Brenda, can I steal this from you for a second? Thank you. So what I did was when I had it emailed to you, so like section 1 says life satisfaction. That's actually the life satisfaction scale from Diener. I would have found that. So I put those into sections. So question 1 on your survey represents question 1 here. So what you'll see is basically section 1 is one scale, section 2 is another scale, and so on. Okay, so what I'm going to do is assume that now we've built the database from all the data from the surveys we've collected. Now we're going to analyze it. Thank you, Brenda. SPSS has 2 windows. A data view, which is where you actually look at the raw data or do your data entry, and then the variable view. Go ahead and click on the variable view. And what you'll see is that the data has actually been fully defined. So for instance, the first 5 items, like on the survey, is the life satisfaction or satisfaction with life scale. So we built the database to be defined so that you know Q1 equals that first item and it represents that scale. Okay? So real quickly, let's refresh what internal consistency reliability is. So score reliability is about the consistency of scores obtained from a measure, right? Remember that conversation? Hello. So it's the consistency of scores obtained from a measure. We really talked about 2 types, one being internal consistency and the other one being test-retest. Test-retest is about the consistency of scores across time. So it's really temporal stability, right? Internal consistency is that consistency of like items on a measure. So you guys have all filled out surveys where you're answering, and maybe 2 or 3 questions later you go, man, that's so similar to the question I just answered. And then a little bit later you do it again. That's what we're doing, is we're asking very similar questions, a little bit different, but all of it is tapping that construct. And so the question is how consistently are you responding to that construct? Okay? And you remember the best example of why reliability is necessary but not sufficient, right? The story of my son and ruptured appendix. So you'll always remember that, okay? Now, we also know that the basic heuristic for score reliability is that values of 0.7 or higher are acceptable, right? So that level of consistency is one way to think about it. It's not wholly correct, but one way to think about it is that 70% accuracy or 30% error is acceptable for us, right? Test retest, we want it to be fairly high. Now, when you think about that, we do it by correlations, right over here, right over here. We do it by correlation. So what we know about a correlation is that it's a measure of relationship between two variables. If we assume that we're measuring the same construct and we expect that construct to be stable across time, the higher the correlation, the better. In fact, we would probably want that in the 0.8s, 0.7. Certainly seen them at 0.6, but as high as possible, okay? So if 0.7 is adequate, what we're really looking for is 0.8 or 0.9. Some of the literature, if we really delve deeply into that, the more critical the decision that is made, for instance, hiring, choosing to hire or admit students into a program, the more or the less error we want. We want higher score reliability because the accuracy is what we're interested in, okay? So medical decisions, we would want even higher, maybe the 0.9, 0.95 level, right? We just, again, the goal of science is the discovery of truth. Error detracts from the discovery of truth, so we want to minimize error. All right? So I'm going to illustrate just how simple calculating or analyzing score reliability is. So everything that you do in SPSS will start with the button called Analyze. So what I want you to do is just click once on Analyze. And then you'll see all of the different types of statistical analyses that we can run. But you'll see a little over halfway down the word Scale. Scale, do you see it? And then you have two choices, either reliability analysis or ALSCAL, or multidimensional scaling. You can obviously tell which one we want, right? ALSCAL or multidimensional scaling is similar, but it's based upon a three-dimensional assessment rather than the two-dimensional. All right, so you have a window or pop-up window that says reliability analysis. On your left-hand side, we have all of our variables. And what we want to do is we want to move all of the satisfaction with life scale items over to the blank window. You can do it individually, or you can click on one, press your Shift key, highlight them all, and move them over at once. Got it? Okay. So far I've clicked what, 2 buttons? Reliability analysis, then I just moved the items over. If you click on Okie dokie, or OK, sorry. I'm from Western Oklahoma, so that has meaning there. If you click on OK, we're going to get an output, 2 tables. The first table tells us how many people were in our sample, right? And how many were excluded due to missing data. But we get this Cronball's alpha. Now you remember from our very first discussion, Cronball's alpha is a measure of internal consistency. We either talk about alpha, the Greek symbol for alpha, internal consistency, or Cronball's alpha. They all mean the same thing, okay? So when you're reading articles, they'll use any one of those 4 terms, okay? Now, the resulting value is 0.851. Is that acceptable?
Hi.
Yeah. So we see good internal consistency. What we don't know from this output is how each individual item contributed to this score. Okay? So what I'm going to argue for is that we actually want to run a little more complex analysis. So I want to just go through it one more time. Analyze, scale, reliability. We've already got the items there, right? So instead of just clicking on OK, let's click on statistics. So I just added one little layer of complexity. And we're not going to go through 3/4 of this, okay? All we are interested in is this box called descriptives. So click on those 3 boxes: item, scale, and scale if item deleted. Okay? And then OK again. So you see we get a little bit more information. So that's the basic formula for score reliability. And so what we're looking at is the individual item, how variability on the individual item across all of the items is relative to the total variability. Now, the only reason I'm highlighting the symbol, one, is when I get stressed out, I go straight to formulas because it calms me down. Second thing is that I want to highlight for just a second the importance of our response format. So if you look at my handout that I gave you, the actual survey, Brenda, can I see that again? Thank you. What we see on this score reliability is that there's a 7-point Likert type response format. Okay, a Likert type response format. How often have you seen a survey that has 3 possible items, or 4, or 5, or 10, or more? The reason that that is important is because what happens with the number of choices that you give somebody influences the variability available on that item. The more options you give them, the more variability there is. Higher variability is associated with higher alpha. Okay? So a 4-point Likert type response format will have a slightly lower score reliability than a 7-point Likert type response format. It's just the nature of the statistics because it's tied to the number of items plus the number of response categories. So if you want to increase your measurement capacity, use the higher score or the Likert type response formats, okay? It's just a methodological artifact. Okay? 2 things outside of our measure that influences score reliability is the Likert type response format and the number of items in the measure itself. Okay, thank you. And like I tell my students, we will never look at formulas again. Okay, never look at those again. Well, unless I get stressed. Yes, it does. You see the formula and automatically shut down, even though it's simple math. All right, so it really is. It's no worse than basic algebra, right? Those of you who took college algebra were so much more advanced than statistics. The math is much simpler. It's basic algebra. All right, so the last time we analyzed, this was the only box that we received, right? Right? This time, because we chose the item statistics, those 3 boxes, scale, if item deleted, and I think there was another one. So what it does is it gives us the individual information. So the average score for the first item is a 4.55, right? The mean for the item. The standard deviation of the item. Remember, I said standard deviation of the item matters. So if we actually want to improve the score, we look at those items that have tighter or smaller standard deviation. Okay? We could actually think about eliminating those items to increase our score reliability. Standard deviation is simply error. Okay? Oh, here's a good stat joke for you. If anybody asks you if you know statistics, you go, certainly, it's only the theory of error. That's everything you need to know about statistics. That's all we're interested in, is error. Okay? Yeah, and it'll become a little more apparent with this table. So in this previous table, it was the item level statistics, right? So each item's mean, each item's standard deviation, how many people were in the analysis, right? This next box gives us information of the item relative to the scale. To what extent does the item contribute to the scale? So if we got rid of this item, here's what the mean would change to. Now, let me immediately go down to this final box. With the total 5 items, okay, with the 5-item scale, this is the average score, 22.38, right? If we got rid of this first item, the mean would drop because we got rid of an item. The standard deviation would, the standard or the variance would change pretty dramatically, actually. And then this is the correlation of the item to the sum of the other items. Okay? How is this item correlated to the total of the others? Does that make sense? And so we want these values to be 0.4 or higher. Okay? And so what we know is that our score reliability was a 0.85, right? So if we got rid of the first item, would we improve reliability? The answer is no. So we're good with that item. Can we improve the measure by getting rid of any items? No. Then we're good with our measure. First of all, it produced an adequate score reliability, and there's really no items in the scale that are contributing error. In fact, they're all working, right? So the basic question that I'm asking is, can I improve the measure? And the answer is no. We're good. Okay? I will tell you for any publication that you're going to do, that first box takes care of everything you need to know. I'm just saying if you want to get more in depth into the items, and that'll become apparent in just a second. Okay? Can you do it? I love asking this question to my students. Can you do it? Are we good? Because my response is, let's just see about that. All right? So let's go back to your survey, and let's do HOPE, my personal favorite, right? So HOPE is comprised of these 12 items. This section has 12 items. Do you see it? But what I need to tell you is that HOPE is an 8-item scale. But there are 12 items in here. So there are 4 items that don't belong. Okay? So let's go ahead and calculate or compute score reliability on all 12 items, and then we'll get rid of the 4 items that don't belong, and you'll see the changes in reliability. Okay? So analyze, scale, reliability analysis. By the way, if you Google score reliability and SPSS, it'll actually give you the screenshots on how to walk through this, okay? So don't fret too much. I mean, we'll go through it multiple times, but it's just such an easy process that piece of cake. All right, so the HOPE scale, luckily we created our database such that we can identify those just because we labeled them HS and then the individual items. So what I'd like for you to do you still have this? It looks like this. I'm going to make you mad, but you don't know it yet. Go ahead and click reset. Okay? And then now we want to move all of the hope or HS, hope scale items. There will be 12. Okay. So now what we need to do is, if we just clicked on OK, which let's do that real quick. Click on OK. So we know that all we're going to get is the one box that we're interested in, which is 0.668. Is that adequate? Right? Is anybody feeling like, well, it's close? It's close. If you round up, it's close, right? But what I want to tell you in statistics, it either is or it isn't. There's nothing almost, okay? This is where we contribute to the 70-some% of correctness, right? So it's close, but it's not there. If we were to just go ahead and create the total scale score out of those 12 items, most people would go ahead and say, yeah, all right, it's close, right? It's all right. But what I'm going to show you is that what you've done is you've just introduced a lot of error because you didn't use the scale correctly. When we go and get the article that I presented the other day, it presents those 12 items as the hope scale. If you read the fine print, it tells you 4 items are filler items. Okay? So why do we do this? Why do we throw in something that doesn't belong? Here's the deal. You guys, we all do it. You're filling out a survey. Pretty soon, you realize that it's worded a certain way, and so now you know that it's a 5-point Likert type response format. So you just kind of glance, and then you go answer. Glance, go answer. And what happens is that creates a perceptual set, a response set, where now you're only looking for the cues. That is the main pieces of the item. And now you're just responding. That's not good for us as researchers. What I need to do is interrupt that perceptual set. So what you'll see on the scale, item 8 says, I feel tired most of the time. Item 10 says, I'm easily downed in an argument. Item 12 says, I worry about my health. And then item 16, those are the filler items. They don't belong, and what they're trying to do is get you to stop and see something different. Okay? Otherwise, all we're doing is contributing to error because all you're doing is looking at the cues. We're just trying to interrupt that process. Survey design is actually a difficult process, but you're trying to capture truth, right? So let's go ahead and go back to analyze, scale, reliability analysis. But this time, before we click on OK, click on statistics. And we want those 3 boxes checked in the descriptives. Okay? Click on continue and okie dokie. So again, we're familiar with the Cronball's alpha box, and then we remember that these are the individual items, right? But what I'm really interested in is this final box. And so one of these filler items, I feel tired most of the time, right? We can see what happens if we get rid of it. But what I'm really interested in is look at the way that it's correlated to the total. So all it is doing is adding error. If it's not correlated, it's error. Okay? And you can see that we can actually increase score reliability if we delete the item. And we actually see that in some of them, some of the items. So it's an indicator that you don't have the scale created as it was intended when you start to see this. Okay? So let's go back in. We're going to get rid of these filler items and rerun the analysis. So analyze, scale, reliability analysis. I feel tired most of the time, Q8. Just click on it and move it over. I'm easily downed in an argument, Q10. Get rid of it. Q12, I worry about my health. And then Q16, I usually find myself worrying about something. So I'm getting rid of items 8, 10, 12, and 16. Getting that out of the analysis. Now, I've only brought over the 8 items. Now, I could have done that from the very beginning and just moved those 8 items, but I wanted to highlight the fact that put in the wrong items, create the wrong scale, you're doing nothing but adding to error and detracting from truth, which is the goal of science. Okay? Now, remember earlier I had you hit the reset button? Go ahead and click on statistics real quick, and you'll see that those buttons are still actually clicked. That's why I was going to make you mad, but you didn't know it. If you don't hit reset button, all of those things are always set up for you. Okay? So it's just more efficient to not hit reset. So just click on OK. We went from 0.67 score reliability to 0.85. So we went from 40% error to 15% error. Okay? And it matters because if you look at the formulas for things like correlation, ANOVA, t-test, regression, all of those assume there is 0 error in the formula. To stop the perceptual set, to get people to stop and read the items. I'm gonna make that more pronounced in just a minute. Okay. I'll make that stand out even more.
Can you say that previous sentence again about 0 error? All of them.
Oh yeah, all of our statistical analysis have the assumption of no error in the measures or perfectly measured variables. So if you go to correlation, a chapter on correlation, it'll start with the assumptions, which is normal distribution, linearity, and no measurement error. This is what we're talking about. The assumption is that this reliability score should be a 1.0, and it never will be. Okay, we don't measure things perfectly. Yeah, so as an example, if we develop a scale for the first time, and it is a global measure of hope, right? Global measure of hope. Now, the goal of science is truth. An objective of science is parsimony, meaning to capture truth in the easiest way possible, right? So why use 30 items when you can use 3 if you're capturing the same thing? And that's what we're trying to get out. And then, so really the question becomes, do we have an adequate number of items to represent the construct? That's the question. Okay? So our score reliability is a 0.85 now, if I remember right. And so what I'm looking at is, can I get rid of any more items to improve the scale? And the answer is no. We've got a pretty good measure. That's the hope scale. I want to do this one more time, and then I want to kind of stop. But I want you to look at the final item, section 4, which is self-esteem. Self-esteem. I kind of brought this into the picture either last time or the first when I showed you about internal consistency. I actually used a couple of these items in my example. So, for instance, I feel that I'm a person of worth, at least on an equal plane with others. Now, let me ask you this. If you look through these items, the content of these items, do any of them stand out to you that they don't touch on your perspective of self-esteem? Or do they all sort of have something to do with self-esteem?
Number 32.
32?
Yeah.
So you think that that does not?
Yeah.
Okay. How come?
It says I'm inclined to feel that I am a failure,
As opposed to?
as opposed to I am confident that I am successful.
Yeah, so your certainty of okay.
These would kind of come across as more to capture maybe like a depression.
So this is a great statement. Is self-esteem, should it be related to, conceptually, should it be related to depression? People who are clinically depressed, what is their self-esteem? Higher or lower? Absolutely. That's a theoretical framework, right? And we can test that, which helps us establish the validity, right? So it should be, you should see some of that connection. It's separate but related, right? That's a great point, okay? So some of the items are worded positively and some of them are worded negatively, right? All of that matters, right? All of that matters. Now, in the previous discussion with Hope, I talked about the filler items to stop the perceptual set. Another strategy researchers will use is to use reversed scored items, positive items and negative items, which forces you as the researcher to reverse code the scores before you create the scale. You're adding work to the researcher. And I can tell you that in terms of looking at the literature on the use of positive and negative worded items, it doesn't help that much to use them. So parsimony being an objective, I usually don't use negatively worded items unless the scale itself, is like self-esteem, is set up that way. I try to avoid it because it's hard to recode the data. Each score, once you calculate the scale, you're done. If you make another change, you have to go in and start all over, right? You add more people in the database, you have to start over. And so you can start to get messed up data by doing this, okay? So what I want us to do is to move these items, 30 through 39, and I want you to move them just the way they are, and conduct a reliability analysis. And I want you to remember to make sure that we have the item level statistics clicked on the analysis, okay? So try to run through that by yourself, and I'll give you a few seconds head start. If you get hung up, I'm gonna get it and do it slowly. So I want to see if you can do it yourself. Okay. If you can't get hung up or whatever, just give me a few seconds and I'll do it. Click on Analyze, Scale, Reliability Analysis. And these are all the items that start with RSES, Rosenberg Self-Esteem Scale. Move those over, click on Statistics, make sure the 3 buttons are clicked. Now look, we have pretty adequate score reliability. Oh no, I hope this isn't the database that's already reverse coded. And it is reverse coded. So, so what, we already reverse coded it. That wasn't supposed to happen. Yeah, that wasn't supposed to happen. If it was still the raw data, sorry, that's embarrassing. Can we delete this part of the presentation? Yeah. Oh well, I've already got tenure, it doesn't matter. So basically what would have normally happened in our raw data, these corrected item total correlations would be negative correlations. And our score reliability would be like close to 0. Let me just say this. If score reliability is below 0.70, that's the first indication something's wrong. Something is not right with your data. And the first thing to start with is, what did you do wrong? Okay? What did you do wrong as the researcher? Did you recode something? Did you do data entry wrong? If you have 2 or 3 people doing data entry, are they doing it the same way? You know, if a person's doing data entry and they know you've got a reverse score, some people might be automatically doing that when they're doing the data entry. So start methodologically as to what could have happened, okay? Now the next thing, if it's not anything you have done, the scale just maybe didn't work in the context of your study. So as an example of that, if you look at items 6 through 17, the HOPE items, I've actually conducted a study where that scale didn't work very well. And it was with an organization that does substance abuse recovery, long-term, hardcore substance abuse recovery. And the term, I can think of many ways to get out of a jam. There are lots of ways around any problem, is part of the addiction process. And the scale starts to fall apart, right? It's seen as that manipulation process, which was very interesting to me as a psychologist, but also as a HOPE researcher of what are people thinking about. Because when you're in a recovery, long-term treatment, those are bad things, right? Potentially bad things. And so, again, start with yourself. What did you do wrong? Do you have filler items? Sometimes you get in a hurry and maybe you added items from another scale that shouldn't have been included. How many times, for those of us who conduct research, you put items, mix them up. So you've got item 1 is hope, item 2 is self-esteem, item 3 is affect, item 4 is, and so you've just created a database where not everything's together. So you just need to make sure you didn't bring items from different scale together. Chances are it's going to be a methodological artifact, which is a kind way of saying it's your fault, right? Kind of thing. But first indicator, if score reliability is below that, there's a problem. If it's not part of something you've done, the scale's not really working. If score reliability is around 0.50, right, 0.50 to 0.6 or lower, you're basically flipping a coin every time somebody answers as to whether or not that's truth. You're just as likely to capture error as you are truth. And another thing that it could be is that you're measuring more than a single dimension of something. So when I was doing constructs and we did commitment, I had affective commitment, normative commitment, continuance commitment. If we add all of those items together, bad things are going to happen because each of those dimensions are related to each other in different ways. Okay? If there's a negative correlation between 2 dimensions, they'll cancel each other out. So again, our measures are captured without error. Sometimes that's random error and sometimes that's systematic error. By the way, systematic error means it's your fault. Okay? Any questions? We're kind of coming down to the end. So quantitatively, to analyze open-ended questions, there's a process called content analysis. And what we do with comments is we provide a numeric coding scheme for those. Then you can statistically analyze them. One of the first jobs I had at the Federal Aviation Administration was we did a job satisfaction survey and had 10,000 responses. And we asked a few open-ended questions. It's also a bad time to be a research assistant because you're the one it's going to get to read and code 10,000 comments. So when my graduate research assistants say we ought to ask some open-ended questions, I'm all for it. And then they get to analyze it. Okay. What I would argue is that if you're really interested in the richness that's available in qualitative data, do the interview. Open-ended questions may not necessarily capture the essence of the issue. And I would argue they don't add much value in my experience in that limited format. I'm not saying they're useless, it's just limited. Content analysis, it's the only way you can do it. You bet. Anything else? So this was the third in the series, the final of on reliability and measures. So again, it was meant to be skill-based. So if that skill is you never want to do this again, objective achieved. But anyway, once again, thank you to Shelley for coordinating all of this, getting the food. We've got, it's probably an announcement for the next. So once a month, we will have these series as the plan. Heather is next on the chopping block.
Heather, do you want to tell them what you're going to be talking about?
Sure. So my series will be next month at the end of September, and it will be covering the research process from question to analysis. So we'll be getting a little bit more in depth in SPSS, and starting with a question, taking that all the way through to analysis.
Okay. And then that'll be followed by Dr. Jody Worley doing.
He's doing that
Understanding research design.
beyond our
Beyond randomized control trials.
Yes.
So he's going to look at the different types of research design and their strengths and weaknesses, which I think would be great information. Actually, all of them will be fantastic. So anyway, thank you. I think there's some more food. Stay away from the Oreos. Thank you.